So, good afternoon to all students. Today I am going to briefly describe the topic of Python modules. So, before we discuss this Python module, let us discuss that what is or where from the Python module comes. Library. We must have already known this term during our study in C language. What is a library? It is a collection of modules and packages which together perform some specific type of applications according to the user requirements. A library can consist of multiple modules inside it. Python has got some commonly used libraries, which includes Python standard libraries, NumPy library, SciPy library, Tinker, and Matplotlib library. So these are some of the common libraries which we in Python we have. Apart from that, we in addition to this we also have many other different libraries. Let us come to the first kind of library, Python standard library. Inside the Python standard library, we have different modules which includes math module, CMath module, random module, statistics, and URLib module. So these modules contains function within them which are useful for performing various tasks. And if we try to implement those functions within our program, it is a necessity to import these libraries or modules from these libraries. Likewise, in the Matplotlib NumPy library, which is used for advanced mathematical functionalities, and it will help us to create the tools that will cater to the functioning of the multiple arrays. Likewise, the third library, that is SciPy library, it is useful library which offers the different algorithmic and mathematical tools for different scientific calculations. The Tinker library will provide the traditional Python user interface toolkit and will help the user-friendly GUI interface for different type of web applications that we can design on our own. And the Matplotlib library, which is commonly used in the data visualization, we will see to it during the further course that it will offer many functions and it will offer different tools which will help us to improve the quality of output formats. That means the outputs that we will get by using the Matplotlib library can be in the form of the charts, plots, or different types of graphs. Next, after a discussion on the library, let us come to what is modular programming. Now, modular programming, it is a document with the definition of the functions and various statements within a Python module. That means a program can be participated or it can be partitioned into different individual components, and this is what it is called as modularity. Uh, and so that it is helpful for us to manage the task on their own. And this if we partition our bigger subtask into different modules, and we can solve each of the individual module and can assemble those modules, the output results of those modules, and frame the bigger output. So therefore, modularizing the program has got different types of benefits. The first benefit you see here is the simplification. The Python module often concentrates on one comparatively small area than the overall program. That means we have a manageable design problem to think that we are concentrating or focusing on a particular module. And if we simplify the task according to the modules, it will be very much easier for us to process those tasks, and it will be very much less error prone. The second advantage that it will provide is the flexibility. Modules are frequently used for conceptual separation between the different problem areas. That means less likely that the changes in one module would affect the other module. That means it will provide a flexible environment in working for long programs. Reusability, that means a particular module, the functions within a particular module can be accessed within the different sections of the bigger program. As a result, duplicate code will no longer be necessary. Next, we have a huge scope of this modular programming, can distinct namespace to prevent the identifier classes in the various parts of the program. So these are the modular programming advantages. Next, you see that what are modules. Now, module, as we have just now seen, that it is an act of partitioning the program into individual components, and each of these individual components will be called as modules. And the act of partitioning is known as the modularity. So, a module can be thought of as a separate unit itself within the library. Now, in a Python, a module can be defined in three different ways. Python allows us to create the set of modules, and similar to the regular expression RE module, a Python module can be primarily written in C programming language, and then it can be dynamically inserted at the runtime to any program. Apart from that, we can also have some built-in modules such as itertools module that is inherently included within the interpreter. Next, a module can be a file, that is a Python code which will contain the definition of the functions, the different set of statements, and the classes. For example, a module .py, say example, if we consider this particular example, module.py file is a module which we will create and whose names is example.module. We will see to this particular example in the next part of our presentation. We can employ the modules to divide the complicated programs into the smaller and understandable pieces, and modules also will allow the reuse of a particular code. Now, rather than duplicating the definitions into several applications, we may use it more frequently in the user-defined functions in a separate module, and then use it in our complete module. So, if we consider this example, here you see we have defined a square. Now, this function will square the number passed to it. So, result is number to the power 2, and then the result that is computed is returned. Now, here a module, example module, it will contain the definition of the function square. Now, since we do not know that what will the square function perform, thereby we cannot use that particular function, and we have to use to the power 2 for computing the square of a number. But if we know that how a square function can perform then we have to import that particular module in which the square function resides, and then we can use it in our program. Now, what are the process or the techniques for importing module within our program? We may import functions from one module in our program. For this, we will generally use the import keyword. Now, in the Python window, we add the next to import keyword, the name of the module is import. For example, if we need to import this particular module, example module, we need to first of all write down the keyword import, and then we need to write down the name of the module which we want to import. Next, we can also use dot operator to use the functions within the module name. For example, there is a particular function that is square which we want only to import from the module example. Therefore, we can write down this particular thing in our program. Result equal to example module dot square. That means here what we are doing, out of the module the example module, we are trying to use the function square. Now there are several modules that are available in Python. We have already discussed the different types of libraries. Likewise, different libraries have different modules inside them. So the complete list of modules can be available with the help of the help command. Now, similar to how we imported our module, an user defined module can also be imported like other standard procedures of importing modules. Now, let us see the Python import statement. We have also seen in the previous example how we import, and now next we will rather focus on this import statement in a deeper way. Using the import keyword and the dot operator, we can import the standard modules, and here we can access the defined functions within it. So let us consider this example: import math, print the value of Euler number is math.e. So what we have done in this particular program code is that we have imported this math module, and then we have used this Euler number function within the math module. Therefore, we have written this particular code math.e. Now, after importing a particular module, you can also rename that particular module according to any variable according to our choice. For example, see here in the second code, import math as empty. Therefore, we have imported the math module and we have renamed that module as empty. Therefore, now math module is not present in our program. Math module, the components of the math module is present, but it is present in the form of the empty. Therefore, if we need to write down the code for within the functions within this math module, we need to write down as empty.e. Therefore, we see here that the math module is renamed inside the program. In some situations, it will help us to write down the this particular way of renaming will help, because if the name of the module is long, so it will save some time. Uh, Now here you can see the from import statement. Let us consider this second way of importing this module. Here we see import specific names from the module without importing the module. See, for example, without importing the module as a whole, if we want to import certain specific names from math, import E, that means from the math module, we are just trying to import the function Euler. Therefore, the value of Euler number is E. In this case, we do not have to mention the name of the module, since we have written the first statement that we have imported the math module, and from the math module we are trying to import only the function E. Therefore, this is useful in the cases. To avoid the dot operator in these scenarios, we can also take an example from math import E comma tau. Therefore, you see here from the math module we have imported the two different functions, and we have separated these two functions with a comma. Therefore, when we try to use these functions within the program, we do not have to make again name the module. We can directly name the functions and can get the output accordingly. Next, you see the from import start statement. What is the use of this particular statement? If we want to import all the functions from a particular module, import all the objects in a module with the present namespace, we will use this particular symbol. We will use this particular star symbol for importing all the objects within the particular module. So for that, the general syntax that we will use is from name of the module import star. Now there are various benefits and drawbacks if we try to use this particular star symbol. So therefore, it is always not advised to use this particular star symbol unless we require all the particular things inside a module. For example, let us consider this particular code. from math import start. They are calculating square root SQRT 25, calculating tangent of an angle tan pi. Here pi is also imported. So here what we have done? Here we have imported the all the functionalities, all the functions, all the objects from the math module, and then we have used a particular function known as SQRT within the math module. We have also used tan and pi, uh, both as a particular expression we have used inside our program. Next, if we just want to locate the path of our module, now what the interpreter searches the numerous spaces. It will search for various multiple locations. If we try to import the location or where our module is currently located, Python several directories are searched if the built-in module is not present. The list of directories can be accessed by this particular command syspath. So what will the Python interpreter do? It will look for the this particular module. See here, module is initially look for the current working directory in which we are presently in, that is firstly log, and then we will search for the remaining path. Now, Python also explores every directory in the cell parameter Python path. If the module cannot be located in the current directory, then we will say to it. See here, Python examines the installation dependent set folder when the Python is downloaded. So here is an example: import sys print sys.path. So in that case, what will happen? First of all, you see we have imported this sys library, and we have used dot path function in order to locate the position where our path, this module, resides within our program. So that is all from the introduction to the math modules. So thank you.